let's solve absolute value of x is less than or equal to 3. So really we need to be asking ourselves, what numbers could x be? Yeah, so what numbers after you apply the absolute value would be less than or equal to 3? X equals 0 works, x equals 1 works, x equals 2 works, x equals 3 works. X equals 4 doesn't work, and any bigger also doesn't work. Now we can go back and check x equals negative 1 doesn't work. Oh, sorry, does work, right? So you plug in negative 1 for x, absolute value, that's less than or equal to 3. Negative 2 works, negative 3 works, but negative 4 doesn't, negative 5 doesn't. Note here in all of what we have here, there's no absolute value. Okay, we're talking about what value x can be, so that after you absolute value it, you would have something that's less than or equal to 3. Oh yeah, and 2.9 works, x equals 3.1 doesn't. So here'd be a summary of the x values that work. Okay, so we've got this um, on a number line. We could also write this in interval notation, and here it is algebraically. X greater than or equal to negative 3 and x less than or equal to 3. It's important to really note that we are processing what's going on with this absolute value inequality. So while we're thinking about absolute value of x, we need to provide an answer about x. We're trying to say which x's work. So I want to really separate the idea that there's x and then there's absolute value of x. Those are different but related. So this is a picture of which x's work. This is interval notation for which x's work. And over here as well, we're trying to describe which x's work. So that's why this final line doesn't mention absolute value. This is how we process the absolute value. Often people just keep absolute values around things, and well, you've never really solved for x then, right? Here you've got x by itself, not absolute value of x. Okay, let's look at absolute value of x is greater than or equal to 5. Again, the question we ask is what can x be? Not what can absolute value of x be. We want to know what can x be. So in other words, what numbers could x be? That is, have a number x, apply absolute value, and then is it going to be greater than or equal to 5 after you apply absolute value? X equals 0 doesn't work, 1 doesn't work, x equals 2 doesn't work either. We skip along, x equals 5 works, x equals 6 works. Anything bigger than 5 seems to work, including 5 itself. And then since we started at x equals 0, let's go to the left on the number line. X equals negative 1 doesn't work. X equals negative 5 does work, and anything smaller, anything to the left of negative 5, such as x equals negative 6, that works. So this in the box here, we have at least a spot check of some values of x that work. And again, it's some values of x that work. So every time you see the word yes, it follows a number that could be used as x, or after you absolute value x, you would get a number that's greater than or equal to 5. Here's a picture of what that looks like. In interval notation, we're going to need that union symbol, and that union symbol is always going to translate to an or for us when we write this in algebraic format. Again, the kind of very, very common thing that gets written, which is incorrect, is to stick absolute values in this last line, but we need to provide an answer about x. We need to talk about x while thinking about absolute value of x. Okay? Yeah, in other words, you need to answer the question about what x can be. Let's take a look at absolute value of 2 plus 4x, close absolute value, greater than 10. Now, just real quick comment, this is not absolute value of 6x greater than 10. It's not 2 plus 4 turns into 6 here. That's not what's going on, because we have to follow the order of operations. So at all times, be sure to read everything using the order of operations. So 4 times x happens first, then there's a plus 2 after. Yeah. What we'll do is create a new variable using substitution. U will be defined to be all of the contents that's inside the absolute value. Okay, so the absolute value tells us where to look, but the stuff inside the absolute value is 2 plus 4x. Notice this line here that says u equals 2 plus 4x. There's no absolute value written anywhere there. And this tells us that anytime we see a 2 plus 4x, we can now replace that with a u. So take a look at what's up at the top. If you were to replace 2 plus 4x with a u, then you would end up with absolute value of u is greater than 10. So by choosing the new variable to be all the contents inside the absolute value, we're now left with the situation, a much nicer problem, which is absolute value of just a single variable and nothing else inside the absolute value, and then that's greater than 10. So then we can answer what values of u satisfy absolute value of u is greater than 10, and the picture looks like this. After you spot check, u equals 0 doesn't work, u equals 1 doesn't work, u equals 10 itself doesn't work, but anything bigger did work. Right? So u equals 10.1 works, and u equals 11 works, and so on. We can describe this algebraically in inequality notation as u less than -10 or u is greater than 10. Now that we have solved for u, this is the time to replace each u here with 2 plus 4x. So if 2 plus 4x is less than -10, or 2 plus 4x is greater than 10. Now we're going to need to subtract 2 on both sides of both inequalities, and then divide by 4 on both sides of both inequalities. We end up with x is less than -3, or x is greater than 2. We can draw that on a number line, and we can also write that in interval notation.